6.1, integration by substitution. Let's remind ourselves what we can do so far with integrals. We've done the power rule, we've done the integral of sine and cosine, and we've done the integral of e to the x, and of 1 over x, of course, which is a natural log. So in order to integrate more complicated functions, we're going to need to have more techniques or rules, and one such technique is called U substitution, or sometimes just substitution. But first, let's talk a little bit about notation. So remember, we were using both of these notations when we were finding derivatives. dy dx equals f prime of x. And if you were to take this and treat the dy dx like a fraction, which we do this sometimes with calculus, and I were to multiply both sides by dx, then I can isolate dy and say that dy is f prime of x times dx. And so let's look at something like this. If I have y equals x cubed and I wanted to find dy, then we can say, well, dy dx is 3x squared, and then multiply both sides by dx, so I have dy equals 3x squared dx. Over here, let's do the same thing. We have u equals x to the 5/3 power, and we want to find du. So if I do the derivative, that's going to be du dx equals, remember with derivatives, we bring that exponent down to the front and then we subtract 1. So it's going to be x to the 2/3. And then I will multiply both sides by dx. So I have du equals 5/3 x to the 2/3 dx. Okay? So the point here is that the dy dx, even though this isn't technically a fraction, a lot of times we treat it like a fraction. So integration by substitution is basically the backwards of the chain rule, and you're going to see why we call it U substitution in a minute. And then this slide is just showing you that this is what we were doing when we did the chain rule with differentiation. We had something like this, a function raised to a power. We brought that power down to the front. We subtracted 1 from the exponent times the derivative of the outside. Remember, the language I was using was the derivative of the outside times the derivative of the inside. Well, now with integrating, we're going to be asked to find the antiderivative or the integral of something like this, and we're going to end up with something like this. How do you do U substitution? Let's start with an easy example. So what you're going to want to do first is figure out what do you need to substitute for U, or what are you going to let U equal to? Well, if you have something like this, where this is just a function within another function, so I have stuff to the 5th power, and then this stuff is x plus 2, then I'm going to let u equal that inside stuff. So we're going to let u equal x plus 2. And I sort of like to think of this as sort of like a little menu. So now I'm going to take the derivative of both sides of this equation. So when I do the derivative of u with respect to x, we just call that du dx. And then the derivative of x plus 2 is just 1. Notice that we're going to be doing derivatives a lot here, so you're going to have to keep those straight in your mind about which is a derivative and which is an antiderivative. Now I'm going to solve this for du, which just means I'm going to multiply both sides by dx, so I have du is equal to 1 times dx, or just du equals dx. Okay, I'm just going to draw a vertical line here because that's all part of my little menu. Now I'm going to make some substitutions. So I'm going to have the integral, right? Repeat my integral sign. And then instead of x plus 2, I'm going to write u to the 5th power. And now, instead of dx, dx is the same thing as du in this case. So I'm going to write du. Now I just find the antiderivative of u to the 5th power. So that would be u to the 6th power divided by 6 plus c. And I'm almost done. All I have to do now is just back substitute and put that back in terms of x. So we'll call that x plus 2 to the 6th power divided by 6 plus c. And that's it. That's the integral. Now, how could you check to see if that really is the correct answer? And this is actually true for any integral. That's right. You can find the derivative of this. So if I were to maybe rewrite this and call this 1/6 times x plus 2 to the 6th power plus c, and I were to call that f of x, and I wanted to find the derivative of that, remember you bring the exponent down to the front, so that's 6 times the 1/6 is going to be 1, so f prime of x would be 1, and then times x plus 2 to the 1 less power times the derivative of the inside, which would just be 1, and then the derivative of a constant is 0, and so all that works out to be x plus 2 to the 5th power, which, sorry, you can see it down there, And that's what our question was. So it's correct. All right, let's have a look at example 2. So here we have the integral of x cubed plus 1 to the 10th power times 3x squared dx. So again, the challenge is going to be first to figure out what to let u equal to. Well, in the other problem, I had x plus 2 to the 5th power, and I let u equal that stuff that was on the inside. I'm going to do the same thing here. So we're going to let u equal to x cubed plus 1. So this is setting up my menu. I'm going to take a derivative of this function. So that's du dx equals 3x squared. And then I multiply both sides by dx in order to isolate the du. So now in the previous problem, I isolated the du by just multiplying both sides by dx. But what I actually wanted to do was to isolate dx because I need to make that substitution. So I first multiply both sides by dx, and now I'm going to divide both sides by 3x squared. So du over 3x squared equals dx. Okay, and just draw a vertical line there to sort of separate my work because this is now all part of my menu that I will use in my substitution. So I want to do the integral. Now I'm making my substitutions. Instead of x cubed plus 1, I'm going to write u to the 10th power. And instead of 3x squared, well, I'm going to leave the 3x squared there, actually, and you're going to see what's going to happen in just a minute. And then instead of dx over here is equal to du over 3x squared. So if you want, you can think about this as being multiplying by du over 3x squared. So you'll notice that now, hey, 3x squared and 3x squared, those reduce to 1. So now I actually have the integral of u to the 10th power du. And now everything is in terms of u, so I will do my antiderivative. So that's going to be u to the 11th power divided by 11, or we can do 1 over 11 times u to the 11th plus c. And then finally back substitute it in terms of x. So we'll have 1 over 11 times x cubed plus 1 to the 10th power plus c. And you could find the derivative of this to see if you do in fact get that, and you have to use the chain rule. So, whoops, it's supposed to be 11. So what I wanted to mention here is that if you look closely at this function, you might recognize, and it's useful if you can recognize this, that this function is actually saying the integral of f of x to the 10th power times f prime of x dx. And that's often a clue that you're going to need to use u substitution when you're doing an integral, is if you can see that you have a function and its derivative all within the same problem. Other than that, how do you know what to set u equal to? I'm supposed to say, how do you know? I think I've had this PowerPoint for years and never noticed that mistake. How do you know what to set equal to u? So determine if you have a function and its derivative in the same interval. Like I was saying here, we have a function and its derivative within the same interval. And if so, you're going to let u equal to the function. If that doesn't apply, look for places where one function is inside of another function and let u equal the inside function. So like this could also use your logic here. Let u equal that inside function. And then be aware that sometimes u substitution does not work. Now, I'm not going to give you any problems and ask you to do u substitution and u substitution don't work. But in life, in calculus, there are some times when you have to try a different technique. So for number 3, you can probably see that the derivative of this 1 plus x squared is 2x. So we have another situation where we have a function and its derivative within the same integral. And so that's a clue that we're going to use u substitution. So hopefully you figured out that we're going to let u equal to 1 plus x squared. So we're going to take a derivative. So du dx would be 2x. And then we want to isolate the dx. So we can multiply both sides by dx and then divide both sides by 2x. So we have du divided by 2x is equal to dx. So I've set that aside. That's my little menu. Now let's make our substitutions. So we're going to have the integral of, I don't have anything to substitute for 2x, so I'm going to leave that. Then the 1 plus x squared, that's going to be now u squared. And instead of dx, I have du over 2x. And so just like in the previous problem, those two x's reduce to 1. So now I have the integral of 1 over u squared du. And I need to find the antiderivative of 1 over u squared, which you may recall, we need to call that u to the negative second du. So now we can add 1 to the exponent and divide by that new exponent. So that's just going to be u to the negative 1 divided by negative 1 plus c. And then let's do a little bit of rearranging here. I want my exponent to be positive, so I can put that u to the first on the bottom, and then that negative 1, if you'd like, you can put that on the top. Because remember, with a negative in front of a term, it doesn't matter if it goes at the top or the bottom. And then finally, I just need to back substitute. So we're going to call that negative 1 over 1 plus x squared plus c. You can probably see here with number 4 that we don't have anything like a function and its derivative all within the integral, but I do have a situation where I have a function inside of another function. And so I'm going to let u equal to the inside bit, which is 4x minus 5. Now, I will say this while I'm thinking of it. Sometimes when you're doing u substitution, you might not be sure what to let u equal to. So sometimes you try something, and then you go through the process, and when you do all your substitution, all of your x's should reduce out. They should disappear or cancel, if it were. But if that doesn't happen and you have like u's and x's all in the same expression, you can't find the antiderivative of that. You need to get everything in terms of all u before you do the antiderivative. So sometimes you have to go back and try to let u equal to something different. And then again, like I said, sometimes a problem cannot even be solved by u substitution. So that's super fun when that happens. All right, so we're going to find the derivative here. I'm going to skip some steps now. Instead of saying du dx, I'm going to go ahead and call this du equals, and then the derivative of 4x minus 5 is just 4. And I'm just going to go ahead and skip that next step where I move the dx over. And so then I have du divided by 4 is equal to dx. Okay, it's my little menu. Now we'll make our substitution. So I have the integral of the square root of u, and instead of dx, I have du divided by 4, because over here dx is du divided by 4. All right, so a couple things that are going on here. I have this divided by 4, which, you know, you can call that, well, let's do two things. Let's call that u to the 1/2 power, and then we can call that times a 1 over 4 du. So this 1 over 4 is just a constant. And remember, with integrals, you can pass constants to the outside of the integral. So let's do that. Let's call that 1/4 times the integral of u to the 1/2 power du. Now I have everything in terms of u, so I'm going to go ahead and do my power rule, find the antiderivative. So let's just carry that 1/4 into the next step, and we're going to have u to the 3/2 power, so add 1, divide by 3/2 plus c. And of course, dividing by 3/2 is the same as multiplying by 2/3, so I really have 1/4 times 2/3 times u to the 3/2 plus c, and 1/4 times 2/3 is 1/6 u to the 3/2 plus c, and then we'll back substitute to put it back in terms of x. So that's 4x minus 5 to the 3/2 plus c. Let's have a look at number 5. Now we've got some trig here. So I have another situation where I don't have a function and its derivative all within the integral, but I'm going to go ahead and try this one with u substitution. I do have a function inside of another function. So hopefully you figured out that you're going to let u equal to 2x. So that means that du is going to be 2 dx. So again, I'm sort of skipping steps now. And then I'll isolate the dx, and I'll have du divided by 2 equals dx. So now I'm going to make my substitution. So I'm going to have the integral of the cosine of u, and I sometimes like to put a little dot for the multiplication, even though it's not technically multiplication. We just sort of treat it that way, du over 2. And so much like in the previous problem, this divide by 2 is the same as multiply by 1/2, which is a constant. So let's go ahead and pull that constant out. So I have 1/2 times the integral of cosine of u du. So now this is pretty clean. We can find the antiderivative of cosine, which is sine. So I have 1/2 times the sine of u plus c, and then we'll back substitute. 1/2 sine 2x plus c. And of course, if you found the derivative of 1/2 sine of 2x plus c, you would get cosine of 2x. Number 6. So here's one where you can see that we have a function and its derivative all within the same integral. The function would be the x cubed plus x, and then the derivative of that is 3x squared plus 1. So let's see how this one's going to turn out. We're going to let u equal the function, so x cubed plus x, and then the derivative of that would be 3x squared plus 1, and then you have that dx there on the outside, and then we isolate the dx, so we have du divided by 3x squared plus 1 is equal to dx. So I make my substitutions. So I'm going to have the integral of 3x squared plus 1, I don't have anything to substitute there, over u, and then instead of dx, I have du over 3x squared plus 1. So this works out very nicely. Again, we can just reduce the 3x squared plus 1. That reduces to 1. So I have the integral of 1 over u du. Now, I did this problem on purpose because these are cases where students always want to call that u to the negative 1 and then use the power rule. But remember, you end up with 0 with the power rule, so that's a clue. It's a big red flag that you can't do the power rule with this. You have to remember that the antiderivative of 1 over u is the natural log of the absolute value of u plus c. And then we back substitute, natural log, absolute value, x cubed plus x plus c. Number 7. So here I have the integral of e to the 3x plus 1 dx. I don't have a situation where I have a function and its derivative within the integral, but I do have a function within a function. So hopefully you can see that the 3x plus 1 is inside of the e function. So we're going to let u equal 3x plus 1. Let u equal 3x plus 1. So then du is going to be 3 dx. So that means that du divided by 3, or sometimes you can call that 1 over 3 times du is equal to dx if you want to be fancy. And then we're going to make our substitution. So the integral of e to the u, and then we have the 1/3 du. And so just like with the other problems, that 1/3 is a constant. Let's take that out of the integral. And we have the antiderivative of e to the u du, which of course is just e to the u plus c with that 1/3 there. And then we back substitute, put it back in terms of x. That's 1/3 e to the 3x plus 1 plus c. Voila.